Hi, my name is Mai Sawada. In this video, I will be demonstrating Challenge Assignment 2 home monitoring system. In this assignment, we were required to implement 3 home monitoring systems. First one is doorbell sound with button press. The second one is the burglar alarm with loud sound above certain threshold. The third one is fire alarm with light intensity above certain threshold. The burglar alarm can be armed and disarmed by pressing a button. The red LED indicates the burglar alarm is enabled, and also green LED is indicated burglar alarm is disabled. We are also required to incorporate watchdog timer, which I use code from Challenge Assignment 2. I did it before. So here we are in main. First, I hold the watchdog timer. And then I initialize clock, ports, timer, license, and ADC. So here you go to init clock.c. Here you can see I initialize all the clocks that will be used in the timer. Here look at the initial init port, which is gonna be in port.c. Here I configure the LEDs. And also port 1.1 switch for doorbell. And also this is for port 1.4 switch to enable and disable the burglar alarm. And this is also for switch. Port 2.7 is for the buzzer sound. Port 2.4 and 2.6 for RGB, the green and red LEDs, which indicates if the burglar alarm is enabled or disabled. We'll go back to main and go to timer.c. Here I declare all 16 and 32-bit timers. This is the initialization watchdog timer and different timers that will be used to make sound, and also the duration of the sound. So one of the challenges of this assignment is using many timers, because we have to generate many different sound with different duration. By using many timers, I have to enabling or disabling or changing time period and duty cycle for correct timer for each operations, which was challenging because it might mess up with the other timers that would mess up the sound too. So at the bottom you can see this is the interrupt functions, half-minute, half-second timer interrupt to clear the watchdog timer. So every half second it clears the watchdog timer, so it prevents from system reset. Going back to main, after I initialize all this, I start watchdog timer and it's going to infinite loop. And in infinite loop, it's checking the fires. So here you go to fire.c. The check fire function in fire.c gets data from light sensor and store into lux. If lux is above the light threshold, which I set it equal to 1500, this is declared in macro.h. And if it's above the threshold, then it will start generate PWM for the fire alarm sound. It will also enable interrupt for the fire alarm, so I can count the period for to sound the alarm and also stop the alarm. Also, I am disabling interrupt for the doorbell and the burglar alarm, because the fire alarm has the highest priority. so it cannot get preempted by other alarm systems. So this fire alarm A2 handler, which is enabled in the interrupt function above. So this is called after fire alarm is on, and this interrupt changes tones and also fire alarm sound. So it sounds like a fire alarm. So in main, I'm just calling these functions, but burglar alarm and doorbells are handled by interrupts. So if you look at the switch.c, there's a switch. So this is the switch interrupt used for port 1.1 for doorbell, and also this is for port 1.4, and this is for the burglar alarm. So if the doorbell switch is pressed, it will make doorbell sound and enable switch debounce interrupt to handle switch debounce, which you can see down here. This is the switch debounce interrupt, which was enabled if the doorbell switch was pressed, or the other burglar switch was pressed. And this also enable the other interrupt to change the tone and time period for the doorbell, which you can see here. Depends on what the time period is. I change the tone, and after the second tone, it stops the sound by using this stop timer. So going back to the interrupt, if port 1.4 was pressed, then you can see that if the green LED is on, then turns off the green LED, enable burglar alarm. However, if the LED was red, then turn off red LED and turn on green, and I deactivate the burglar alarm. So going to burglar.c, this is where I need the EDC, and this is the interrupt function used for the burglar. So at the sample EDC interrupt, this happens every 100 milliseconds. So if this, what is it? If this, every time this toggle conversion trigger is called, it will trigger to take ADC sample by enabling this ADC ISR interrupt above. So it takes the ADC sample, and if the ADC sample that is stored in the current ADC result is smaller than because the louder the sound is, it's gonna be smaller. The threshold, microphone threshold, set to be 7500. Then I turn on the burglar on. This is the flag to indicate the burglar alarm is on. And also I disable the doorbell sound because the burglar alarm has higher priority than doorbell. And if the burglar is on, then going back to this interrupt, and it generates the sound. and change the tone. Depends on what sound it is. And this is all going to be disabled if the switch for the burglar alarm was pressed. So I think this is one of the optimization I use speed up is disabling lower priority task when it is performing higher priority tasks. So it is not wasting time by going into unnecessary interrupts. And the other optimization I used was, let's see. Here's some of the buys. List of the buys for the power. Most of them recommend me to initialize all the ports, but I did not take care of them because of it will cause to consume more powers and use more memory. Other things I did actually optimize was here this optimize assistance to compare speed versus memory. This does not support on Mac, so I have to actually run this on a PC. And this is the screenshot of it. And I use the most efficient, which is this one, in order to enhance, in order to optimize my code. And now I'm going to show the demonstrations.